Hi students, welcome. In this video we will study about constant temperature process. So here students, constant temperature process is also called as isothermal process, or it is also called as hyperbolic process. So here students, we will first understand the definition of constant temperature process. So here see, if a system undergoes a process in such a way that during the process the temperature of the system remains constant, such a process is called an isothermal process or constant temperature process. Okay, now see here in the we will see PV and TS diagram. So here this is first PV diagram. On PV diagram you can see here it is a P1 T1, and here it is a V1 and V2, and here it is a hyperbolic curve. Because of this it is called as a hyperbolic process. And here it is a TS diagram. As you can see here, T1 and T2 is same at this point, as here this process is constant temperature process. So here temperature is same, that is T1 is equal to T2. Okay, now see here property relationship. Here this equation, that is P1 V1 upon T1 is equal to P2 V2 upon T2, is a general property relationship equation. And here in this case the as temperature is constant, so here T1 is equal to T2. So after simplifying this general equation we will get here P1 V1 is equal to P2 V2. Okay, this, as you can see, when we go further in this process we got here PV is equal to constant, that is P1 V1 is equal to P2 V2. Okay, now see here, now we will see the work done. The work done in constant temperature process is given by, here we can calculate the work done by area under the curve on PV diagram, that is this area, or we can calculate mathematically by these equations 1 2 3. So here first equation is work done 1 to 2, W1 to 2 is equal to P1 V1 ln V2 upon V1. Okay, then W1 to 2 is equal to MRT1 ln V2 upon V1. Then W1 to 2 is equal to MRT1 ln P1 upon P2. Here m is the mass, r is the characteristic gas constant. Okay, and see here P is the pressure, T is the temperature, and V is the volume. Okay, now see here change in internal energy. Change in internal energy is given by the formula delta U is equal to mcv T2 minus T1. As we know here T1 is equal to T2, so here we will get this term is 0. So because of this, then delta U, that is change in internal energy, is 0. Okay, now change in enthalpy. Change in enthalpy is given by delta H is equal to mcp T2 minus T1. As we know here this is the constant temperature process, so here T1 is equal to T2, so here this term becomes 0. So delta H, that is change in enthalpy, is 0. Now further here see heat transferred. Heat transfer is given by the equation this, that is Q is equal to integration of 1 to 2 T ds. So here after simplifying we will get T into bracket S2 minus S1. So here see Q, that is heat transferred, is given by delta U plus W, that is heat transferred is equal to change in internal energy plus work done. So here see change in internal energy is 0, and W we have here these all work done we can calculate by these three equations. So here we have now Q is equal to W. Okay, heat transferred is equal to work done. Now further change in entropy. So here change in entropy, that is delta S, is equal to integration of 1 to 2 delta Q upon T is equal to integration 1 to 2 delta W upon T is equal to integration 1 to 2 PdV upon T, and we can write down the equation of change in entropy as delta S is equal to mR ln V2 upon V1, delta S is equal to mR ln P1 upon P2. So students, in this video we have understood about constant temperature process. Thank you students for watching this video. Like, share and comment for this video and subscribe my channel. Thank you.